I think for me, the biggest change, to your point, is in terms of my entire career, we always called it R&D. So everyone had research and development. But in most places that I've worked at and most people that I know, 90% of the companies up until, let's say, a few years ago, everyone was just like development. There really wasn't a lot of research going on inside of them.
Most engineering teams don't do hard research. They do development. I mean, you need to research and implementation, but that's different. They're finding and deploying other teams' breakthroughs. The research muscle, the ability to systematically explore unknown ideas, that's a skill that most companies never build. Adam's team at Hyper-Exponential, or HX, which operates in the insurance technology space, is questioning exactly that. They have a dedicated research engineering team whose job isn't to build features, it's to audit the AI, run evaluations, scan the space for emerging technologies, real R&D. Adam says that his job is to ensure that the team is always working on the most important thing. To do that, or at least to do it well, you need people whose full-time job is finding out what that most important thing is.
So our group, I think we're something around 11 people now, but we are growing pretty fast. So we're definitely hiring and looking for people all the time. We have engineering, design and product marketing and research engineers. And maybe that's the more interesting part. So the way we have it set up is I'll start from the research engineers standpoint. So they have kind of two primary functions within the team. First, they run all the evaluations. So they own the evaluation framework and they basically do all of the pipeline review. So kind of on a weekly basis, we have pipeline review where we look at the agent pipeline itself against our evaluation set and look at the performance. And they generate what we call failure reports, which basically show us, okay, on which cases has the agent failed. And they try to do root cause analysis to give some indication of like why we think it's failing. And then that gets handed over to the engineers. And it's not something I invented. I got this inspiration from a number of people. I kind of advise that it's sort of like checking your own homework, that it's better if the engineers don't do the evaluation themselves. You sort of have kind of like a third party. So the engineers build everything and the research engineers audit it as well.
The separation really matters. It's like a model evaluating its own output. It's a check against confirmation bias. You see what you want to see in your own work. But there's a second function. These research engineers, they spend their time scanning the horizon, new papers, new frameworks, new capabilities. Unlike traditional code, which had a certain speed of progress, keeping up with AI is a full-time job, so HX made it one. When they find something promising, they spin up a proof of concept, they test it, and if it works, they throw it over the wall to the engineers to productize. Research flows into development, development flows into product.
And the second function that the research engineers play is to do really just outbound research on new technologies, new systems, because it is moving so fast. It's really not hyperbole to say it's like a full-time job just to look outwards into the market. But what we're looking for is to kind of scan the horizon constantly and make sure that we've seen everything. And then the research agent will basically pick what we think is the most interesting for ourselves and then boot up a POC. And they basically present a potential POC that we can make for something upgrade that we can do. They'll run that POC, present back the findings. And if we think it's compelling enough, then that gets thrown across the line to the engineers. And then we'll basically scale that up into a real feature. One master file system in this kind of product engine. All the repositories are there. And our research agents also live inside of that. So we kind of increasingly keep downloading all these. And if you have your agent and you have all the repos exposed, you can even ask the agent to read through the papers or audit things and then look at your code base and already think of ways it could be incorporated. And I think we'll probably get to the stage where the agents will build the POCs and then we'll basically kind of audit those, and the research agents will just manage ensembles of these agents, pulling in things from the internet, testing it, building a POC and refining it. So that's kind of moving in that direction. We really try to anchor ourselves around this kind of master file system where all the repositories are, because that actually becomes this plane which everyone exists on. So everyone has full access to the code base, and increasingly everyone is developing features. So we have other ancillary teams in the company which are really excited about what we're building and what we're doing. Some of them are even internal consumers. So we have a professional services team that can build models for customers. So they are like best first customer of the agent. And what we want to do is expose the repository to them and even kind of have an open source model where anyone in the company can basically submit a pull request or a merge request. and use Claude on their own and develop kind of a feature they want to submit and then pull it back in. So I think increasingly the code base will have kind of tier one support on like the core engineers, and then it's kind of diffuse base of people that are contributing things back into the system. And that's actually like a muscle that a lot of engineering teams don't have, is like how to actually do research, right? So I focus on that a lot in our team, like how are we good at that? Or how do we get better at that? So I spend a lot of time thinking about how we become better as a research org. And then there is also the development side, which is, okay, once we have it, we need to build it, productionize it, scale it up, and attach all of the systems that we need to make it really work. I mean, there's a science and discipline to engineering, and there is a science and discipline to research. It's not just we sit at a whiteboard, we do some ideas, and then we go through it. I mean, there's like really serious skills and practices. And so I worked in ML for a very long time. So you build up a lot of that process of, okay, how do we test new versions? How do we run A/B tests? How do we like build hypotheses around things and kind of build that rigor around it? So I think that's going to increasingly, not to the level of, traditional data science of building the models themselves, but I honestly think at kind of many levels of engineering with AI, you're going to spend a lot of time doing research because you are going to try to tackle things, and maybe that will subside as sort of the frontier becomes known. But I think no one is really clear on the boundaries of where things will stop. So you need to spend a lot of time researching that unknown space.